in activity question, week 1, week 2 for practice question.
So can you please describe the schema, sir? Because I'm not getting the logic of behind it.
Sandeep, can you speak louder? You are not audible.
Sorry, sir?
Can you speak louder? You are not audible.
Yeah, sir. Just I want to ask about the schema, sir. Just I'm not getting the logic of behind it.
I'm not able to get you. Pradeep, Subhendu.
Sir, he is asking about schema.
Okay. Hello. Hello.
Yes,
Am I audible? Am I audible, right?
Yes, yes, you are audible.
First I want to give the schema as using. I want to define the schema using some example. So let me share my screen. You all know about the class and the object, right? Hello.
Yes, sir.
Yeah. So can anyone tell what is class and what is the object?
Yeah, class is the template, like template, and like you can create the object of that class, like how many ever object you can create, and object will hold the like state of that, like object will hold the state information. The class will not hold the state information. It is just the definition.
Yeah, it's like the blueprint. Suppose the class dog, right? So dog store the information of the name of dog. Suppose name means the breed or something, right? And here is the, am I audible? Hello?
Yes, sir.
Yeah, and this is the color. Suppose, right? And the object is the particular information of, suppose this is the dog one. So this is the this is the variable, and this is the, suppose this is the one instance, or the, you can say the object, the real world object. So dog one, suppose the dog one name is, right, Ricky. Okay, and the dog one color is, so okay, right. So this is the template, and you create, using this template you create the object, right? So you can think about the similar way. The schema is the that template, and whatever the instance we create, so that these two are the analogous. You can think about like this. Hello. So this is the one relation. Suppose this is the one relational schema is given as the attribute A, B, and C. And particular one instance is given to you like that. The A value is as the 1, and the B value as the A, and suppose C value is something like CD, right? So this is the one instance of that. Hello, you can, yeah. So this structure, you can think like that. The schema is the structure of that particular table, right? And the table name is R, and these are the attribute. Attribute means characteristic of that, represent the characteristic of each instance. So suppose in the real world, you can see similar thing. Suppose you want to create the relation of dog, right? Relation and the table are the same thing, right? So suppose you want to create the relation of, or the table of dog, right? So you can define the dog relation as name, attribute is name, and second one is color, right? These are the attribute. Attribute means characteristic of that. and the value, whatever is the value. So suppose this is the Ricky and color is the black. So this is the instant, right? I hope it is clear to you. You get idea about this,
Yeah.
what is relational and what is the instance.
Yeah, so if you define, say, for example, certain constraint on the schema, like that will also be considered as schema, or it is something different?
Yeah, you can define that also in the schema, right? So generally we define a schema like this. You can also define the what are the data type of that. So suppose this is the, I have here write as the int, right? So after that you have also, you can write the A is int data type, hence the B is, right? B is varchar, okay, and like this. We also
Yeah.
defined like, so it is the blueprint. You can think about the schema as the blueprint of that table.
Yeah, what I'm telling is, say for example, like this is the data type that you define for those attributes. Okay. Now, say for example, if I define some constraint, like say for example that A is not null. Okay. Is that also be part of the schema, or it is something different?
No, that is also the part of schema.
Part of the schema. Okay. And where the schema is stored actually?
So schema is stored in the data dictionary, right? So data dictionary is one table inside the database that store information about what is the table name. Like this is also a table, right? So this is also a table. Data dictionary is also table. It stores the what inside that particular database is stored. What are the table name? What are the column name? So it stores the what is table name, right? Table name. What are the column name inside that table? So these are stored inside this data dictionary. So this is also called this stored the data about data. That's why also calls the metadata also this thing. So it is stored the information about this particular table is stored the data, and this is also stored the data about data, right? Data dictionary. So that is metadata.
So for data dictionary, this schema is an object, right?
Hello?
For data dictionary, like
Yeah.
the schema definition is the object.
Yeah.
Okay. And say for example, if there are two table name, they are same. Okay. So how that will be maintained in the data dictionary?
Okay, that is not possible in the database, in the single database too. Not possible similar data.
Okay, so that means say for example, whoever is working on that database, you can only create say for example, if multiple users are working, okay, and then you create it I create a table and you create another table, but unfortunately the name of the table is same, like it cannot, it is not possible.
Yeah, that it's so the table is already exist.
Okay.
Okay, any other doubt?
So is schema prefixed by user dot schema, like username dot schema?
Username schema.
See, the reason I am asking this question, like say for example, if you work with Oracle, right? In Oracle, you can create multiple instances. So that means, say for example, user 1 create a table called R, okay, and user 2 can also create a table R. The table R one R will be referenced as u1.r, another will be u2.r.
In Postgres, I think it is not possible.
Okay,
So,
okay, understood.
Yes, in Postgres we can create a different schema for it. Like for by default it is public, but we can create. Once we will discuss this in week 2, we will go through this. Okay.
Okay.
Yeah.
any other doubt in the activity or the practice question? You can ask.
Sir, activity 1.4, question number 11.
Activity question. Okay, let me check.
1.4, question number 11.
Yeah. The question is, which of the following decision is or are part of the logical design of?
To share on the screen, sir, the question.
Okay, let me take the screenshot. This is the question, right?
Yes, sir. Question number 11.
Yeah. So the question is, which of the following is or are the content of the data dictionary? So in the data dictionary, as we discussed with that.
Yeah.
So it stores the database schema. We already discussed about that.
Yeah.
And data instance. So data instance is the actual data. So that we not stored in the data dictionary. We only store the information about the data relation, right?
A schema, only a schema.
Only schema. So a schema contain also the integrity constraint.
Now, where this instance is stored, then database instance, the particular value of that schema. Am I right?
Yeah. When we
where
discuss,
it is stored?
So it is stored inside this particular data dictionary. So data dictionary is one table inside that Postgres or your database that is stored the table information, column name and
data dictionary is a nested table, we can say.
No, it is not nested table.
Okay.
So it is that you can say for the each database there is one data dictionary which stored the information about the relation, right? Whatever the relation inside that database, that is stored the data dictionary.
Okay.
So you can think like this also.
And integrity constraint.
Yeah, so it like this is stored the table name.
Okay.
Right. And inside the table name, there is one column name. Right.
Yeah.
This is one table column name, and this is the data type. And these are the constraint.
What does we mean by the constraint here? Constraint on the
constraint
what?
means constraints means suppose this is the column A.
Okay.
And if you want to insert the value inside the column A between means it you want to store the integer, suppose like greater than 0 and less than 100. So that is the constraint. You applied some condition.
Okay. Conditions
Yeah,
given
yeah.
to put the values in this column name.
Yeah.
Okay,
that is known as the
it.
constraint. Yeah.
Got it.
And authorization is also here inside the. So suppose you cannot give the access to all user inside.
Okay. View, either view constant or editing constant like that.
Yeah.
Okay. Got it. It is such type of nomenclature for the non-background of this programming people. We are from the non-programming side. So this terminology is giving so much difficulty because we are directly, the programmers are teaching, just assuming that we are knowing all this terminology. Like MongoDB, Couchbase, Codashell, we have never heard in our life. Then we have to go to the Google and then search it. Then we go to the decide whether we are activity question doing. If honestly we are doing, then we must know all the terminology.
Yeah.
So basically, if you are follow the slides, you can easily answer the activity question. If you follow the lectures,
in the lectures they are not describing this. MongoDB has never been mentioned. Couchbase has never been mentioned. No words have been used, but directly it will ask. The answer is there. The answer has been mentioned, but the answer is not mentioned in the activity question. They have not mentioned. So this is the constant way we are doing. But if it is possible, then the terminology, whenever it is either in the activity question or in the lecture, it must be defined properly.
So you
for
will
the
be
non-background.
Yeah, integrity constant, authorization, database instances, and schema. You will be learn in very detail way in week 2 and week 3. So don't worry.
Okay, fine. Okay, thank you.
And see, like as he told, right, if you can include those things in a little bit of tutorial, right, say for example, like when you use MongoDB, like what circumstances, like where you will use MongoDB, or probably a relevant application, like okay, if this is the kind of application, there you can use MongoDB over any other DB or whatsoever it is. That will be helpful. Otherwise what will happen, that will open up a question mark, and then it will be very difficult to like get the answer, like exact answer.
Yes, Raju. So actually, this is week 1. We are just giving the overview of the content. So this MongoDB, this CouchDB, these are different types of database. So in this course, we are only following the relational database system, that is our Postgres. So this MongoDB,
like that is okay, sir. Like what I am trying to say is, like if you say few words about MongoDB, that okay, this is the kind of application where you use MongoDB, not much about that, but that will give us a fair idea. Okay, like the kind of applications we are going to do is not related to that, but it will give us an idea. Okay, what is MongoDB? Like we should not be in a like surprise, like whenever it will be asked somewhere. Okay, if this is the kind of application, what kind of database will be your choice?
yes, right. Yeah, okay. We can discuss this whatever the unfamiliar words are there in the tutorial, or we can discuss in the next session also, like these few things. Okay, just the overview of this. What is this and for what purpose we use that? Okay, that will be
Yes,
fine, right?
that will be helpful. Yes.
Yeah. Okay.
So sir, one question, like generally in a relational table, like we store data in a like a row format, right? Like every row like represents the object. Okay, every record. Now, is there any database like where we can store data in a column format?
Column format. Like in a relational database, we store the tabular format, right? We define the column, that is basically attribute, and the instance of that, right? Basically a row.
Correct. So your each record is is a row, right? Where you fill up all the attribute values. Now, is there something like is there a kind of database available in the market like which stores data in a column format?
Columnar database, I think one is there. Pradeep, you know about?
Column format, you means you want to store each record as the columns, and
Right.
And you want to store that particular column value in the reverse order, right?
Not reverse order. Actually, like, see, I was reading some element like on that OLTP and OLAP. Okay, like what I came across is like during like when you use the database for OLTP purpose, that time you use tabular data, right? That means the data is stored in a row form. But in a row format, like when you do a search, okay, like like you'll have to store say for example, when you write a query, select xyz from so and so table. Okay, so what it does, it will basically retrieve all the rows first, then it will take a projection of on those attributes, right? So now if you look at this, like it is like a processor intensive, right? Now say for example, you have a OLAP kind of database where you your most of the operations are read only. Not read only, like it is yes, you hardly write to that database. You generally do a lot of search operation, right? In that kind of things, like you store data in a column format, so that if I ask you that select like a column A from this relation, what it will do, it will only read that column instead of reading all other rows. Okay, so that way it is optimized. So that was like only I understood, but not understood completely. So just that was the reason I asked this question.
That is the part of NoSQL, right, Pradeep?
There are certain databases called columnar databases, like unproprietary one is like Amazon Redshift. So specifically these are useful for like time series data. So like where you are querying certain columns, whatever you have said. So specific example will be like in financial markets where storing that nanosecond levels data. So that is helpful, like querying those columns and all. So whatever you have said. Yeah.
Okay.
Rajiv itself, right?
Yes. Like at least like I can verify that okay, the understanding whatever I got from like reading those materials is like aligned.
Hello, sir.
Yeah.
Sir, in practice assignment, question number 3 and 4.
Okay, let me check.
So let me share my screen. So my screen is visible, right? Hello?
Yes, sir.
Yeah, visible, sir.
Yes.
Okay,
yes.
so question number 3 is, by the concept of logical data independence, a change in the logical level of DBMS should not affect which other level of abstraction.
Yes,
So
sir.
what?
My doubt is for question number 3, the answer is view level, and for question number 4, the answer is both both logical and view level. So means why it is so?
So see, so logical data independence means if you change in the logical in logical level, it should not affect the view levels. And in physical data independence means if you change the physical level of data, it not change the logical levels, and means upper level logical and view levels both.
But here, like say for example, like I also opened the same thing on Discord. Okay, the point here is like if I view this as a layered architecture, okay.
Okay.
View is in the top. After that, your logical level, and then your physical level. Okay.
Yeah.
If you take the reference of any layered architecture, like take the reference from OSI, okay. So your any upper layer will give a service, will send the data to its lower layer, and it gives some services to upper layer. Okay. So if I take that as a like a anecdote, then your logical independence means that your view should not get affected.
So so if you change the means logical data independence means if you change the logical level, your view should not be affected,
right?
And in physical data independence means if you change the physical levels, should not be affected other levels, means upper levels, means
Logical level, not
logical level,
only logical level.
no, and also view level also.
No, but view cannot directly talk to physical layer. View has to go through your logical layer, right? That is a layered concept. You cannot skip a layer. If you skip the layer, then it is very difficult to manage any software, right? There will be like a lot of ripple effects. You won't be able to even manage that. It will be fragile.
So see physical, if you change the data structure or if you change the hard disk, it should not be affected the logical levels and also view level, so right?
No, but why it has to like view level has to concern about that? Because physical layer is a lower layer, right?
Yeah.
Now, physical layer gives support to my logical layer. So physical data independence means I can comfortably replace my physical layer without impacting my higher layer, just layer above me.
Yeah.
Correct. So your physical, if you change the physical layer, your logical layer should not get affected.
Also
absolutely
view levels. Yeah.
No, when you say view level, then my question comes like, does that mean your view level also depends on physical layer? It should not. It should depend only upon logical layer. That's all.
Yeah. So if we make any changes in view level, it should not affect the logical level, right?
Correct.
Yeah. Yes, that is correct. Yeah.
But so in that way, like if you see this question, it should be only the view, not both logical and view, because when you say logical and view, then the like a concept of layered architecture go for a toss actually.
No, see, physical data independence, what it will do, it will not allow to affect change in the logical level. And ultimately, logical data independence, it will not allow to change in the view level. So if we go to that concept, the both logical and view level should not be affected, right?
Like indirectly, I can say, okay, view level will not get impacted, but not directly. Directly because view is like far away from this physical layer.
Yeah, so by the property of physical data independence, logical level should not be affected, right?
That's all, correct.
Yeah, and also by the logical data independence, the view level will not be affected also.
Correct.
Yeah, so both, in this case, question of both will be the answer, right?
No, but here the question is like your physical data independence, right?
Yeah.
Physical data independence means like your logical layer should not get impacted due to the change in physical layer. That's what even mentioned in the slide as well. But when you extend that to view level, there the like I have some reservation actually. Yeah.
Yeah. So if there is physical data independence, then it will not also affect the view level, na? There is one diagram in the slides. Yeah, just one more. Yes, Subhendu, can you take that diagram data abstraction?
Okay, sir. Let me share my screen. Hello, am I audible?
Yes.
Yeah. Yes.
Oh, see. So physical data independence means so view level, then logical levels, and the physical level. So in view levels, what we want to show, that we describe the view level. In logical levels, what are the attributes, and the logical means what are the relationship among the attributes, and the physical levels like data structure and the hard disks. Suppose physical level independence, suppose if you change the physical this level, it should not be affected the logical. Suppose if you change the hard drives or data structure, it should not be the affect logical levels and also the view levels.
Here you can see, right, physical level is lowest level of abstraction. It will not affect the higher level.
No, we can understand, like we can understand that part, like indirectly view will not get impacted. Now, see, view even doesn't know anything about physical layer. Correct? View even doesn't know the way, even if like whatever the implementation is, how the logical layer will be implemented. In the logical layer, there will be some code which will work using some interface defined in the physical layer, right? That way your logical layer is coded. And view layer even doesn't know like is there any interface defined in the physical layer. So physical layer independence, like all higher layer, if there are, say for example, any other layers above view layers and all those will be independent explicitly.
Yeah, so directly it will not affect.
Directly it will not affect, right? So that means physical data independence, since it is a layered architecture, ideally the answer should be only logical level, because if you see even the OSI layers, right? For example, if you change the physical layer, your application layer will not get impacted. That is the layered architecture.
Yeah, so okay. So your concern is about this ambiguity in the question, right?
Yeah, like that's what, like I see there is an ambiguity in that correctness of that, because you can indirectly say my view is view will not get impacted, that is okay. But if I need to answer that from a layered architecture perspective, I will answer only logical level.
See, these are the level of we have seen these are the level of abstraction means in database. In OSI means we are not going to learn operating system. So these
No,
are
that is
the
okay. I just took the analogy.
so this is the just levels of abstraction, not layer architecture. We cannot I cannot compare.
Okay, it is not layered architecture, you are saying.
Yeah, so it is a level of abstraction. So
Okay.
If I will get back to you next session in detail way. So
Is
if
it,
you
that will be helpful.
is it a level? Is it a level or layer? Or
it is
both?
levels of abstraction.
I think it is a level only to just define
physical
level and logical level and view level. And layered architecture, I think it is a higher level of architecture. I think so.
No. Even in layered architecture, you define abstraction, and when you define abstraction, that time you get you give birth to different layers.
I think in the layer it is minutely defined, but here I think it is not minutely defined. The physical level, logical level, and the view level. It is just understanding of the abstraction of the three layers. I think so, because in the first week I'm not. I think so. It is like that.
Yes, it is the understanding of levels of abstraction in database.
Yeah, just perfect, because you know the higher level of things. So you are confusing with the. We are not confusing. We are just understanding the three things. That's all. Because we don't know the layer structure. Maybe I think in the higher week it will be clear. Sir, it will be convenient if such type of nomenclatures and distinctions are in separate notes to be circulated first. Then we come and jump into this discussion, so that we should be solid in our logic, because your time and our time is also. If it is possible, like short keynotes, other than the lectures, keynotes available to be, I think, discussed here. In the mathematics too, keynotes were there, key points, 1, 2, 3, 4, 5, like that. So that other definitions, we are searching from Google and Wikipedia or like that. If it is compiled, then it will be better. If it is so.
So we are
learning. Ultimately, we are learning the new thing.
We have suggested one reference book for this, simplest threat and cause. You can refer to that only. So we'll suggest you, whenever you have any doubt in any terminology, you can go through that book. Okay. We are also following that book only throughout the course.
Yeah, book. In the book, we have to follow that, right? Yeah. We have not taken this. We have to go through the book. We are going through the book, but I think if it is compiled in the short, then it will be easier. Otherwise, we are going through that book.
See, if you want to learn in detail, you have to go to the reference book. There is no shortcut.
Yeah. You are absolutely right, sir.
Yeah. So this is the introductory part. Whatever is required for this course, we'll cover that part.
Okay, fine.
Yeah. So only small portion is there about the database architecture. So that we are going to cover in the week 7. Okay, yes, any other doubt? And in this week, we have provided the overall view of our course, right? So whatever the terminology is there in this week, we are going to discuss in detail in the later week, okay?
So sir, in the second week, we'll be installing Postgres?
Yeah, so it's better to install the PostgreSQL and load the database before the week to release, right?
Okay, before week to release.
Yeah,
So is there any document like uploaded or?
Yes. In the portal, you can see PostgreSQL resources.
Some resource from the
Yes,
structure is uploaded there, but we could not understand how much.
Okay, so if first we'll take the question. If we have a time, I will show how to install the PostgreSQL. Okay, today.
Okay, fine.
Okay.
Any further question on week 1?
Can you please explain object-relational data model?
Data model, yes.
1.5 question number 2.
Activity 1.5.
Yes, sir. Question number 2.
Okay, question. Pradeep, Sugandhi, take any question.
It's regarding object-relation data model.
Question number
2, second.
Oh, practice question or activity question?
The activity question 1.5, second question.
Let me check. So the question is, which of the following is or are true about object relational data model, right?
Yes, sir.
So object relational model is the extension of relational data model, right? So whatever support in the relational database model, that is also support in the object relational model, right?
Okay.
So I think you all know about the relational data models. We takes the column value as the atomic value.
Where we define data into a tables format.
Yeah, in table format, and each value means column value we take as the single value, right? So that is the atomic value. Okay. And the second point is, it is originally intended as a document markup language, not as the database language. So it is the database, right?
Not a markup language, no, sir?
Yeah, that is not the markup language. So markup languages are, for example, like the HTML are the markup language, or the XML are the markup language.
Yes, extensible markup language.
Yeah.
Okay. It is used in semi-structured data model.
Semi-structured data model? Not. So it is just in the object relational model. Well, what we have introduced, each data is we see as the object. So you know about the OOPS concept. So we introduce that OOPS concept in the relational data, object relational data model, right? So there is several concepts in the OOPS, like the class or the object or inheritance property, that we introduce in the relational data model. So we can model our real world object, right? So data present in the real world object, that is easy to use in the object relational model. Okay. So
sir, in object, Yeah, go ahead, please.
Yeah, tell me.
Yeah, so in object relational model, like you are saying, like you can define an object like which will go and store in the database as a relational model. That is the kind of things, or is it something different completely?
In the object relational models, we stored everything as the means one column, right? So in the object relational model, we everything treat as the object, right? So each record is the object, one object. Each record means one row is one object, like this. I just gave an example of that, the class and the object. So here each instance, I give the example of the instance. Instance is in the relational database model. And what is the object relational model? That is the this instance is treated as the object on the relational database model.
No, but okay, now let me ask this question. Say for example, you have a object relational model, okay? In that case, like you are say for example storing two student information, okay? How will you be storing that? Is it in a table form or is it a key value pair?
It's in table form now.
So okay, so it as the object, right? First we define is the another tables of that. Let me give an example.
Because it is in a relational data model, that's why it is stored in a table.
Please.
Correct.
With example, we will be able to understand properly.
In relation RDBMS, we store data in table format.
Yeah.
Then
tell me.
So then we store data also object relation data model in table format, no?
Yeah. I just want to give an idea about that. So here you can see, this is the relational schema. This is the structure of the RDBMS, right? RDBMS means a relational database management system. And in the object-oriented relational database model, this is the extension of that, right? Hello? Yeah, am I audible, right?
Yes, sir.
Yeah, audible, sir.
Yeah. So this is an extension, or in this model, we everything treated as the means object, every. So this is an instance. So this particular thing in the object relational model, we treated as the object, right?
Okay.
Like
instances are treated as an object.
Yeah. So like.
But sir, ORM, like when you say that object relational model, I think like it was defined like say for example, when you are using Hibernate as a programming language, okay, Hibernate framework, there in the program you can define an object like true object, Java object, which when you persist, it will finally go and store in that Postgres database as a in a table form. Is it that ORM, like object relational model?
Yeah. That is
the one, right?
Yeah.
Yes. So underlying storage is exactly same as RDBMS. Only thing like when you the how you stored is that ORM framework, object relational model framework. Yes, understood.
So suppose the one example, like you want to store the address, right? Address column. So in address column, there is the street number, right? Okay. And the street number, city, or state, right? So you can define this thing as the one data type and store this information on that particular column. So this is the one data structure. We define this as the class, not class. Yeah, you can define as the class.
Yeah, as
some data type
Java
struct.
class. Yes.
Yeah, or the struct. You know about the struct, right? So
yes, structure.
Yeah, so we can store in the object relational model as the data type, but in the relational data model it is not possible. So we only consider the atomic value. Atomic value means only the single value, right?
Correct. Integer, varchar, those are atomic.
Yeah.
Here
only
your entire address is atomic.
Yeah.
Because the underlying framework will support that.
Yeah. I hope you can find out what are the third option is. It provides the upward compatibility with the existing relational language. Yes, this is the correct option also. So it allows the attribute of the tuples to have the complex data type. That is also possible in the object relational model. It allows the set or the list or this kind of the data type struct, right? Hello, who asked that question?
Yes, sir.
Yeah. So A, C, or D are the correct option, right? Is it clear, right?
Yes, sir.
Clear. Atomic value means single valued function.
Yeah. Single valued attribute is possible in the relational database model, and and object relational model is the extension of that. So it is the backward compatibility.
Okay.
So can you please explain the option number C and D?
You are not audible. Can you repeat your question?
Yeah, so 1.5, question number 2, option number C and D. Can you explain, please?
1.5.
Question number 4.
Question number 4.
Question number 4. I think that question is directly from slide, right? Which of the following is true about the XML, extensible markup language, right? So it was. So this is the theory question. So I'm not going to just give an introduction about the XML language. So it is similar to the HTML language. So it is used for the data stored or the data transfer, right? So it is easy to extract that. We can, using the XML, we can transfer the data from one over the internet, right? Okay. Hello.
Yes.
Yeah, and whenever we migrate, we can also use that XML database. XML data.
Hello, sir.
Yeah.
I have one basic question. I think so far you already discussed, but still I'm a bit confused about the physical level and the logical level. I understand the concept like physical level could be the lower level, and it involves the only structure of the table or database, whatever we call it as, and the logical level could be having the relationship between the attributes which relation between the data. But could you please take one example of the table, and then could you please explain what exactly that physical level, what exactly the logical level, what would be the view level? I understand it's completely like user interface that I completely understand. Only physical and logical level I'm a bit confused, sir. Just one example briefly if you give, that would be really helpful.
Oh, okay. So you first thing you have to understand that everything this abstraction means just means it is logically present, right? So it is not physical. So everything you see as this is the one level as the physical level, this things in the physical levels, and this thing as the logical level, and this is as the so that is logical. Everything you suppose you want to store some table like the employee.
Okay.
So you first create and one means you using some database like the Postgres. So using the Postgres, you create this thing as the creatable statement, like that's the creatable statement, like the ename, right? Ename of the type varchar, like this, and address is also varchar. And suppose the salary is integer type, right? So you create this thing in the Postgres interface, right? And after that, you stored some information about the employee one. So suppose name is.
What is this? Varchar means characters, 5 characters and 20 characters.
Yeah. Varchar means variable character. So this is the.
Okay. Got it.
Yeah. So suppose the name is A and the address is K, and the salary is suppose 30, right? So you work this thing in the Postgres, and you store this thing in your computer, means some storage, means secondary storage. Somewhere you store that things in the physically, right? Okay. So this thing is stored in the physically on your secondary storage, means your hard disk or somewhere else. So that things we are kept as the hide from the user or whoever working on the logical levels, we hide. So how this thing is stored in the means secondary storage, this thing will hide from this whoever working on this the logical level. So this thing is physical level. So how the stored, which data structure?
This signifies the physical address in the memory, in the secondary memory. Is it so, no, sir?
Yeah.
Every data is having a physical address in the secondary memory.
Yeah.
We can say. Okay.
So you are unaware about that, how this thing is stored in the database. But you can see whenever you run some query on the database, you can directly see from your your interface, right? So you only know aware about this thing. So this is the structure of your data, and these are the stored information, right? So this thing is logical. So in the Postgres user, suppose you develop some application. So there is the one user you want for, you develop some application for the user one, and you only gives the access to the who are the employee working on that. Suppose this is the some X company, and you want to give the access to the user one that only access the ename and the address, not the salary. So for that you have to create some view. So suppose you create the view one, right? So you give the access of this particular. So suppose this is the view one. View one only gives the access to the ename and the address, right? So He is not aware about that's the what is the structure of this physical, not physical, this logical structure, right? Hello.
Correct.
Yes.
Sir.
Yeah.
Correct, sir.
So
Listening.
this is the
Level.
view level, right? Okay, and this is the logical level.
So, sir,
yeah.
So what attributes to be stored in the database means how it should be stored. Everything will be defined in the logical level. Only the data source will be stored in the at a physical level.
Yeah.
And view level means it's whatever the child parts of that data, whatever the data we required, we'll just pull that data and then we will see it.
Yeah.
Okay.
So I hope it is clear to you what is.
So very clear, sir. Thank you very much, sir. Now I think now I understand. So earlier what I was thinking is whatever you just explained logical level, I thought that was physical level actually. I thought that physical level means we define the structure. So that's where I was getting a lot of confusion while going through that videos. But now I'm clear where I'm making that mistake. Thank you, sir.
So user one,
yeah,
a logical level, something is hidden. That is why it is called abstraction. Is it so?
No. You can also give the access to the salary data.
Okay,
so, but so in the view levels, there is a possible answer different user. So you cannot. So you are the student of like the IITM online degree program. You have the different access, right? You have different access. Instructor has the different access, and who are the admins? There are the different type of the access on their database, right?
What is abstraction about this physical level and view level?
Here, what is the abstraction?
Yeah, here in this example, what is abstraction? This
in the view level, you are not aware of the what is the data structure. You are not aware about so what is the variable type of this ename. What is the variable? You are not aware about that, right?
This is abstraction.
Provide only the this is abstraction. I hide the background details about that.
Yeah, background details is hidden from the user one, and different users, they are only authorized to use whatever they have been given to access.
Only particular section of the data.
Yeah, this is abstraction, right? Thank you. So nice.
So one last question from my side. So can you briefly explain about the query processing and the store manager responsibility? Just briefly, just concept wise.
Okay.
Just, I mean, I will just to tell you where I'm getting confused is parser and translator. Will that parser and translator step, step converts the data into some logarithmic forms, or after that it happens? Some confusion is there. That is the main reason I'm asking this question.
Okay, let me take the screenshot of that. What is your specific doubt? I only explained that. Okay.
Yeah, sure. That's fine. So
it is present in the lecture number 125, right?
Yeah. I think it's almost like end of the slides. That is in introduction to DBMS2 videos.
This one, right?
That flowchart, exactly. Yeah, this one.
Yeah,
this one. So my first question is about that query. Query means, my understanding is that so we create a database. Query means from user some request we got, so that we call as query. Is it correct, sir?
Yeah. So suppose there is one database. Suppose this select star from select. Suppose ename from the employee, right? This is query. Okay. So suppose there is one employee table. Okay. And the employee has the ename and the address, as we discussed, address and the salary. Okay. And we perform this query. Select ename. We want the name of the employee from that particular company. Okay. So the query is like select ename from the employee, right?
Yes.
Hello.
Yes, sir.
Yeah. So after that, the parser and the translator, what will do? It will parse this query to so that the machine can understand, right?
Okay.
Okay. So after that, after this is converted into the relational algebra. So relational algebra you can see on the, I think, week 3 or week 4. So we convert this as the SQL query, right? SQL.
Okay.
So we convert this thing into relational algebra expression. That is relational algebra expression, something like select select ename, then table name. What is the table name? Right. So we will discuss in the I think this thing we discuss in the chapter week 4, and this thing we in details in I think week 11 or last week we discussed.
So
this is just an introduction about it. So after that we see this thing in the converted as the relational algebra. Then we see which of the relational algebra. So corresponding to this query, there is maybe several relational algebra, and after that, which of the optimized one, right? So which is the cost effective, right?
Okay.
Okay. Then we plan for some execution plan, how to go about that we execute, right?
Yeah.
So after that, we extract the data from using the evaluation engine.
Okay.
Then we returns the query output.
Okay. Okay.
So sir, here,
yes,
go ahead.
Yeah. Hello.
Yes, Rajat.
Yeah, someone was asking some question actually, like.
I am telling something. So same diagram we are going to see in the last week. So in that, in the last week we'll be discussing just how to convert this SQL query in relational algebra, and what are the best optimized, like how to optimize that particular relational algebra expression. So that thing is there in the last week. So I just want to say that. Yes, Rajat.
Yeah. So if you can share the screen once again.
Yeah.
Yeah, when you say this execution plan, right now, say for example you have done some optimization and then you have come up with the execution plan. Okay, now is this plan stored somewhere, say for example like for a future query?
No, this is the, I think this is the based on the whatever's the input come to you. Hello.
Yeah, say for example, first time like you send a query like select ename from employee table. Okay. Now it has a execution plan. Okay, now say for example, second time you run a query, different query, select say for example like employee ID from employee name, employee table. Okay, now the execution plan might be same, right?
Yeah.
So is it going to store that execution plan in some cache so that whenever my second query on that particular relation will come, it can at least use that execution plan? Because every time you compute execution plan like that is that will be like recomputing same thing again and again, right?
Yeah.
So do you is it stored somewhere or what?
So yeah, Rajiv, currently I am not aware of that. Anyone know this particular? I will. Hello.
Because this execution plan is generated for the each SQL query, right? Because if you change the condition, then the optimizer will take the different relational algebra expression. It will not be the same expression.
No, but then what is the use of this execution plan actually?
See, execution plan like it will. Do you know the concept of indexing?
Yes.
Yeah. So we store the record in the we create one index, and then based on that we store some particular record. So in the execution plan, that will be shown. Like
no, but didn't understand actually. You are saying like first your those relations has to be indexed.
Yes. So once we create a database, it will be already indexed, right?
No, unless you create an index, like it will it will not create an index automatically. Right?
Internally,
you create an index.
Some database will create an index. Like simply you just created one table, right? So internally, Postgres SQL will take the B tree indexing.
Okay.
Yeah. So based on the particular SQL query, the translator process generate the relational algebra expression, and for the one SQL query there can be multiple relational algebra expression. Among that, which one is optimized, and according to that, it will create the execution plan. So if we simply change select ename from employee, and if we select some basic condition is applied where condition is something, and if you select employee ID, right? If employee ID is the primary key, then it will get executed fast, right?
No, maybe say for example select phone number for from employee. Forget about the primary key at this point of time. Okay.
But still the execution will be different, na, for that particular SQL query.
Yeah, but say for example, if when we say it is a execution plan, your execution plan will be something that okay, first you query this table, then if you are getting say for example you need to bring data from multiple tables, then you get multiple tables, join that information and then add some aggregation or filter. This is a kind of a plan, right?
So that plan is taken from the relational algebra expression, right? So like suppose we are joining two tables and we are applying one condition on one table only. Okay, so there will be two plans generated. What we can do at first, we can join those two tables and then apply the condition on table one, or what? First we'll apply the condition on table one and then we'll join that table with table two.
Correct. Now my question is like whenever this execution plan is computed, okay, will the execution plan be saved somewhere so that the similar query when comes, it won't need to go and
your voice is not clear.
Rajiv, your voice is not clear. Hello. Yeah, so it based on the different database system. I don't know about the PostgreSQL whether it stored the execution plan or not.
Okay, because in Oracle, I think like there are something like you can store like that execution plan is stored so that next time similar query comes for that same relation, it will see like whether it can leverage that execution plan and without recomputation. So that's what I am asking. Like, is it a generic architecture or it is like a database specific?
It is based on database.
Oh, based on database. Okay, perfect.
in Postgres, you can see the execution plan if you just write explain in front of before the SQL query.
Okay.
Yeah. Okay. Yeah. So this is just introduction part of this course. Like as you go through this course, you will be understanding the terminologies behind this. Okay. Yeah. Okay. Any other question? I think we can go for the PostgreSQL installation. Yes. Pradeep, can you stop sharing? Yeah, okay. Okay, is my screen visible?
Yes.
So you can simply go to Google and search PostgreSQL download. Here you can see download PostgreSQL. Just click on it, and depending on your operating system, you can select. So I will select Windows. And once you select Windows, here you can see download the installer. Okay, just click on that. And there are different versions of PostgreSQL. So currently you are using version 10. So when we start this course, version 10.18 was available. So now it is 20. It's okay. It's the same thing. But we prefer version 10 only because whatever the assignment we have created, we have tested this on this version. So the difference between this different version is like simple. Like if you consider the date format, so some version will take the like DDD -mm -DD. Sorry, YYY -mm -DD. Some will take the slash. So some minute changes is there in the version, but we will follow version 10.2. Okay. So based on your system, you can just click on the download. It will take some time. So on the discourse, one student commented that he is using Mac. So Postgres 14 installation is easier than version 10. So you can go for 14 also. But if you are using Windows machine, then please use version 10 only. Okay.
For Windows, which one?
Version 10, 10.20.
For Windows.
Yeah. This one.
Okay.
Yeah.
And for Mac?
For Mac, you can try installing this version also. If I didn't try that. Is anyone tried it? Sorry. Yes. Sandeep. Right. Okay. Okay, you can go to the discourse also if you face any issue in downloading or installing. There are a lot of posts. So okay, so now full screen I have to share this. Okay, so now we have downloaded that PostgreSQL version 10. Just click on that. My screen is visible, right? Full screen.
Yes, sir.
Yeah.
Yes.
Yes.
That's open. Okay, then just click on next. Okay, just note down this directory. Next, whatever this tick here, just do not touch it here. Okay, we have to install all those things. PostgreSQL server pgadmin stack builder command line tool. Then click on next. Okay, so I already installed this PostgreSQL on my computer. So if you are new to this, so what will be? It will ask for the password. Okay, so please remember that master password. So every time when you click on the PG admin, you have to enter that password. Okay. So I already installed this, so that's why it's not asking for the password. But please note down that password. Okay. Otherwise, you have to again uninstall everything and then. Okay, what happened? Present real service shut down before proceeding. Okay. As I already installed the version 12 and 14 on my system, so that's why I didn't ask for any password. Okay. Is anyone trying currently? You can check it. Okay. It will take some time. 1 or 2 minutes. Okay. So we'll be using pgadmin for this, which is a GUI tool for PostgreSQL. You can use CMD also, or PSQL shell is also there. So, but we'll prefer pgadmin only. It is better to use, like easy to use. Okay. Okay, just 1 minute. So if you are logged into the portal, you can see the resources from instructor, right? Okay, here you can see PostgreSQL resources unit, resources from instructor. Yeah, here you can see data set. Already how to load the database in PostgreSQL, we have provided the documentation for that. Instruction is also given. You can go to that. So there are 3 different data sets: University, LIS, and FLIS. In the slides, there are a few SQL queries based on University database, and in the reference book which you are following, same database is used in University. Okay. So for learning purpose, you can use this database in University. You can simply click and download it. Okay, so it will take 1 or 2 minutes to install. Once you download that data set, you have to unzip that. Okay. You can extract it and you can store anywhere. Yeah, so once you done with the installation, you can see this box. Just take on this tag builder. Okay, we don't need this tag builder, and just then click on finish. So that's it, and then you can search for pgadmin. Here you can see pgadmin app. Oh, logo is unprotected. The last one we have used version 10.19. So okay. So yeah, as I said, during installation it will ask for the master password. Okay, so you have to enter the password here, because I already installed this pgadmin. So for me it was not showing. So here you can see Postgres SQL version 10. Just click on this and you have to enter the password again. Okay. So I have already created this whole database, so I will show you. Okay, so before that, you have to set the path preference. Just go to preference, this binary path, and depending upon the version that you are installing, you have to copy paste the binary path here. Okay, so currently we are using version 10. So from where to copy this? Just go to my computer. You can go to Sridhar, then program file.
Binary path for what?
For setting up the path preference. But I will show you.
That means whatever the files we save or create, all these files will be there.
You can go to the C drive, program files, then PostgreSQL, then 10, and then just click on this pin, okay, and just select this.
Okay, wherever the data, those scripts are available.
Yeah.
Okay.
Once you copy that, okay, I'm not sharing my screen. Once you copy that, go to file, then preferences, then binary path, and depending upon your version, that is for version 10, just copy paste it here. Okay, and here also. Okay. For binary path, it is version 10. I already copied this. Okay. So we have to copy paste inside this Postgres SQL binary path. Okay, not here. Yeah, here you can see version 10. Okay. So then click on save. That's it. Now to load the database, just right click on this database, create. I will give the name like University DB. Just click on save. Yeah, so in the portal we have given 3 databases, so you have to download and extract it. And once you created this database, we have to restore that database. Okay, then just right click on this, then restore, then custom or tar file, then file name. So I've already downloaded this and extracted the database. So simply here you can see University, okay, and just click on restore. That's it. Once it is restored, you can simply click on right click and refresh, and you can see the schema. Public schema is there. Inside the schema, you can see the tables. There are 11 tables in University database. Okay. If you want to query anything, okay. So I am not going in detail. Just I am showing you. This will be will go in detail in week 2. Just click on query 2, or you can click here also. Okay. And say suppose you want to see the records in this advisor table. So simple select star from advisor. So don't worry, we are going to run this in week 2. I'm just showing you. Here you can see the data. Okay. So that's it. What are the different options are there? How to use that? That we are going to see in the next week. Okay. So as of now, just download this PostgreSQL and load all the 3 databases. Okay, before week 2. Yeah. Any question, any doubt in this? You can watch a recording also, right, on YouTube. It will be helpful.
Yes. Yes.
So sir, for today, for this week, it will be only downloading the given data and just play around that, right? So next week onwards, there will be some activity.
Yeah, next week onwards, we are going to an SQL. This is just introduction week. You can go through the slide and the content and download this PostgreSQL.
Okay.
So can this Postgres be can we connect to this Postgres from outside as well?
Your voice is staggering.
You can type in the chat box also. Okay.
Am I audible?
Noise is coming.
Your voice is breaking.
Still breaking.
Voice is breaking.
Okay.
Microphone is breaking.
Yeah, so please install this PostgreSQL and load all three databases. Okay. So in the next week, like next Thursday, we will be discussing how to create a database, what is data type, what is constraint, how to define that. Okay, all those things we are going to discuss. So before that, please watch the lecture. Okay.
Yes.
Okay, fine, sir. Any prerequisite for the next week? We should revise for that, which is not covered in the lecture.
No. We'll cover, yeah, whatever is required. But it's a diploma level course, so it is always, we prefer that you should study from the reference book. Okay. You should take reference from the other sources also.
Okay, fine.
Yeah, okay. So those are using Ubuntu and other operating system. You can check the discourse. Many posts are available there. Okay. It will be helpful for you. Okay. Any other doubt in week one? And just uncheck that stack because we don't need that. Yeah, you can watch this recording on YouTube also. Or you can follow the steps for in the documentation. How to load the database. How to load database using pgadmin is there, command prompt and SPS will check. Okay, any other doubt, any other question? Okay. Okay, if you have gone to the activity question, then you can take few question on peer tech platform. Okay, so yeah, Anjana is there.
Yes, sir.
Yeah. So for this course, 4 instructors are there. Me, myself, Piyush Vairade, Anjana Bura, and Subhendu Gorai and Pradeep Murgu. So yeah, so you can, Anjana, you can give your introduction also.
Yeah. So hello everyone.
Yeah. What were you telling, sir? Voice is not clear, sir. Hello.
Yeah, so for this course, we are 4 instructors. Yeah, so I'm just introducing them. So Anjana is one of the course instructors. She'll be taking the PDX session now.
Okay. So I have pasted a link in the chat box. I hope all of you can check that out, and I would request all of you to open that link. So we'll take a few questions there, and you all will have to answer. So these questions will be basically related to week 1 only. So yeah. Okay. You all can join in. Like, we'll wait for some time for all of you to join in.
Please join from your online degree email ID only. Okay?
Okay, so 16 students have joined in. The others, you all can also join in.
You have to write the whole text, physical level, application level like that.
No,
Or
there will be a number of options. So you all can either write down the option number, say A, B, C, D, or you can also write down the answer that you all think is appropriate.
ABCD is not there, perhaps. I think in the mobile it is not visible. Okay.
1, 2, 3.
Yeah, 1, 2, 3, A, B, C, D, anything you can use.
Okay, fine. Thank you.
Okay, so we'll start the class. So the first question is, which of the following levels describes how the records are actually stored? So from the previous discussion, I hope this question will be very easy for all of you. So please go ahead and answer. Okay, so we have got 26 responses here. So we'll just go through the answers then. Physical level. Logical level. Who have answered logical level, can you unmute and please explain why and how? Like you can unmute yourself and just share your opinion, your strategy, why it's logical level. Okay. So again, B. Okay, so the ones who have answered logical level, can you all please, any one of you, can you unmute and tell why? Okay, some of you have also answered application level. So the correct answer is physical level. So physical level basically deals and describes how the data or the records are actually stored in the memory. So the correct answer is a physical level. So does anybody have any doubt in this question?
No, ma'am.
Okay, so we'll move ahead. So the next question is, which of the following levels describes the relationship between the data in a database system? So you all can go ahead and answer. We'll wait for a few time for your responses basically. Okay, so I guess we can check the responses now. So logical level, yeah. Again, application level. Okay, so the correct answer is logical level, as it describes the relationship between the data in a database system. So the ones who have answered a view level or application level, can you unmute and tell, like, anyone? Or is this question clear? Like, does anybody have any doubt in this question?
No, ma'am.
Okay. Okay, then maybe we can move ahead. So, okay. So the next question is, which of the following languages can be used to create new records and manipulate existing records in a database? So please read the question nicely and answer accordingly. Okay, so I think we can go ahead with the answers. So data manipulation. Okay, data definition. Okay. Okay, so many of you have answered data definition language. Okay. Okay, so the correct answer is data manipulation language. So data manipulation language basically deals with like creating new records and manipulating existing records in a database. So some of the commands or some of the statements which are used by DML are insert, delete, update. So when we say that we need to create new records, so we will be using insert. Then when we say manipulate existing records, which can include either updating the record or deleting an existing record, so we can use delete or update command for that. So the answer is data manipulation language. However, the ones who have answered data definition language, so data definition language basically define and manipulate the schema of the database, not the records or in the database. It basically like define or manipulate the schema of the database. So the commands which it uses are create, drop, alter, truncate. So I hope this question is clear. Anyone, any doubt?
Yes.
And data control?
Yeah, data control language, basically it gives like a authorization to the users, like grant, revoke.
Okay.
Yeah.
Thank you. Thank you.
Yeah. So any doubt in this question? Anyone?
No, ma'am.
Okay. Okay. So we'll move ahead. So the next question is, Dash controls the interaction among concurrent transactions in order to ensure the consistency of the database. So please go ahead and answer. Okay, so we have got 21 responses. So concurrency control manager. Okay, most of you got the right answer. So concurrency control manager is the right answer of this question. So anybody any doubt in this question?
No, ma'am.
No, ma'am.
Okay. Okay. So basically concurrency control manager controls the interaction among concurrent transaction. Concurrent transaction basically means the transaction that are happening in parallel. So in order to ensure the consistency of the data. So, okay, so let's move to the next question. So the next question says, a programmer is working on the data structures that store data internally in a database. At what level of abstraction is the programmer working? So please go ahead and answer. Okay, so I guess we can go for the responses. Physical level. Okay. Logical level. Okay, many of you have answered logical level. Okay, so can you explain why the answer is logical level? Anyone? Please unmute yourself. Like it is given in the question that a programmer is working on the data structures that store data internally in a database. So this basically means that the programmer is working in the physical level. Why? Because he is dealing with the data that is stored in the database internally. He is working on the data structures. So the correct answer is physical level. So most of you have got the wrong answer, that is the logical level. So logical level is not the correct answer.
So maybe
when
isn't
will be
the
the programming level?
Yeah, sorry?
When it will be a programming level?
Actually, programming level is not a level of abstraction, basically.
Okay, right.
Yeah.
Fine.
So ma'am, isn't the question little bit like ambiguous? Like he is writing a data structure that stores data internally in a database.
Right.
So when you store data, it cannot be internal to the database. It will be in the file system, right?
Look, it is written that he is working on the data structures, right? So the data structures will be available in the physical level only of the database.
Yeah, yeah.
So
Correct.
the
Database is always.
But if you see the remaining line, data structure that store data internally in a database. So the file that you store actually, that you do not store in a database, you store in a file system. Isn't it?
The question says that a programmer is working on the data structures that store data internally in a database. So he is basically working on the data structures, right?
No, that is okay. Like even if you store your schema, okay, like you can say that okay, he is writing some data structure to store schema in data dictionary, right? Data structure doesn't say like see, actually if I see the line, it is storing something in the database. So that means the database itself is in the logical layer, logical level. So like see, the answer is physical level, that we understand. Like okay, we need to infer from the data structure, but actually it is not writing in a database, it is writing in a file system.
Okay.
Database is itself a file system.
No, database is not a file system.
Yeah, Rajib, I think there is some ambiguity in the question. So we will see and we'll update the question.
Correct, right?
Yeah.
Yeah. Thank you.
Okay, so we'll move to the next question then. Sorry for the problem. So the next question says, which of the following are advantages of DBMS over file-based data management applications? So you can select more than one option. So yeah, please go ahead and answer. Okay, so I guess we can go for the answers. ABC. Okay, yeah. So yes. So ABC is the correct answer. Yeah, most of you got it right. So any doubt in this particular question? Anyone?
No, ma'am.
Okay. Okay. So we'll move to the next question then, the last question. So it says these are the statements. So you have to identify which among these are true. So okay, so we have got 22 responses. So okay. File handling via Python takes less time. D. Okay. None of the above. Okay. So none of the above is the correct answer. So would anybody like volunteer to like explain their strategy why A, B, or C was the correct answer?
Yeah, see, if you read the first line, okay, file handling via Python takes less time as compared to DBMS.
Right.
To me, that is the correct answer. The reason being, DBMS is designed for doing something different, and Python can very well handle file. Okay, so and that will be even faster. And DBMS, we don't use like DBMS as a file handling tool.
Okay.
So that basically we'll have to first define what does it mean.
Hello.
See, when I see file handling, it is the input-output operation with any file, right?
Yeah.
And Python can do lot of file handling with much ease, and DBMS is not designed for file handling. The purpose of DBMS is all different. So
that is true. Like if you need to insert a line into a file using DBMS, it is pretty difficult.
But Python takes more time, huh?
No,
compared to DBMS.
You can open up the like entire Shakespeare and analyze like how many words are there in just a millisecond.
Now suppose you imagine it is a .csv file.
Yeah. So when you're dealing with the Python's the CSV file, then it will take time.
Yeah. I think that is what
file handling will not take time if you want to insert some record or maybe search for something and then go and do manipulation. That is, but file handling is a very generic term.
Yeah, that is the problem is with the question, but file handling
question itself, yes.
Here, what it meant is actually, I think if it is a .csv or something like that, then DB performs much better.
So you can check one video and the professor explain about that's the file handling using the Python and the DBMS system.
Excuse me, sir.
Hello. Yeah.
What is the then correct answer?
So this is the wrong option, right? So file handling via Python takes less time as compared to the DBMS system. So as Rajiv, you said that the file handling via, so file handling come under the many, so CSV file or another data manipulation, right? So that will take time.
Even if you see in a different perspective, like DBMS, if you generalize, it is not talking about RDBMS, right? It is talking about DBMS. So NoSQL is a DBMS, and file handling by NoSQL is much better. So
why we are even considering like handling CSV files or any like specific files and like thinking like
you just take the definition of that DBMS itself,
database management system.
Yeah, and you go for a NoSQL DBMS, then that file handling through NoSQL DBMS is much easier.
No, I think NoSQL is like a lot many times it is perceived differently. That is really NoSQL, but it is not NoSQL. It is not only SQL. If you read the literature, you will see not only SQL. So it supports SQL as well.
Exactly, but the NoSQL is actually meant for addressing data like files,
unstructured data.
Yeah, unstructured data.
Yeah, the entire storage is different. Like a key value pair it stores.
Yeah, but it comes under the DBMS umbrella, no?
See, but
in the video lecture, it is given the file handling in Python will take few seconds. And in DBMS,
so
it will have few milliseconds.
Correct. In the video lecture, if you see file handling, that has been discussed in the context of specifically doing some database kind of operation, that is like write something, search for something, or that kind of things. Okay, file handling is a very generic term. Okay, you can entirely open the entire Shakespeare and find out how many words are unique words are there in milliseconds.
I think this question is concerned with this week 1 only, I think so. File handling.
But if this is the question given in, say, for example, exam, like I will interpret file handling as a general term, right?
Maybe, but I think for this time, this is we are doing practice with this. So for this time, it is concerned with week 1 only. I think a number of terms are not generic. They are concerned with the week 1 only, and the question maker is also concerned with week 1 only. I think so, because most of the terms are being used has been taken from the week 1 only, I think
no,
so.
that is okay, but with the
If I'm not
assumption,
wrong,
like
if I'm not wrong, because you are having the deep knowledge with this, we are not knowing anything. I have come to this week only, and I think I am quite clear that this is correct.
Yeah.
Because file handling via
actually,
Python is there in the lecture. It is clearly mentioned that it will have seconds, few seconds, and it will have milliseconds. So we will interpret like that only. The textbook is that. The video lecture we are following. If
yeah,
deep knowledge is there, then it may be generic. File handling is not done in the DBMS. What you say?
see, file handling is done in even if you see in the foundation 2 programming in Python, right? There was file handling.
Yeah, it's to some extent, but I think
correct.
Python
So that
Python
is the
2,
reason
Python
like
2.
file handling is a generic term.
Maybe you are right, but here I can't comment on them more on this. I don't have knowledge deep about this.
All the activity questions are based on the slides only.
But I have confusion in the third option also, because arithmetic operation, I think in the video lecture that it will be convenient to do in this Python rather than in DBMS. Perhaps it is mentioned somewhere. Arithmetic operations are more easily done in Python rather than in DBMS.
Yeah. That is, I think that is the wrong option. So it is easy to do any set of arithmetic operations.
Okay, right. Yeah, right. Here it is wrong. Yeah, correct.
This fifth question also, what is that confusion? I have not understood that physical fifth question. Just go back. The programmer is working on data structures that store data internally in a database. At what level the abstract, what level of abstraction the programmer is?
Yeah, in that question, actually we are asking the question about how the data is stored, and how the data is stored is described.
That is on
by abstraction in the physical level.
Yeah, he is working in the physical level only.
Yeah.
It is clear. It has to do that how the working on a data structure of how the data is actually stored internally. The keyword over here is internally.
Right.
Yeah. Internally defines the physical level. I think so.
Yes.
Correct. But what Mr. Banerjee was telling, the database internally is not a generic term, because I think something confusion is also there in the question, because this question is particularly designed for the week 1. I think so. Maybe some terminology may differ.
Think from like even this question, if it is asked in exam, okay.
Yeah. It may happen. What you are telling, we
the questions like last 2 questions at least, it was pretty ambiguous statement, because internally in a database, if I take that as a phrase, then it cannot be physical layer. Database is not working in a physical layer. When you are storing some data in physical layer, that means you take storing the data in a file system.
You take the phrase store data internally in a database, not internally in a database. Store data internally, then makes the difference. But you are also right. Somewhere ambiguity is there.
Data, right? You need to store the data in
but
a
let
file
us take
system.
it easily here. In the
you have to store the data in a file system.
Yeah. You are telling that is also right, but here I'm not having so much knowledge to comment on.
Like I can tell you about Oracle. When you write some create
because
some
I
objects.
don't know Oracle, that's why it is clear.
No. Like since I do not know Postgres SQL, I cannot tell you the exact file name, but I can tell you the exact file name in a Oracle database. If you are, say, for example, populating some table, right? So that means you are writing some data. The data will physically get stored in a .dbf file in the file system. That is the physical storage. And how you define what will be the structure of that dbf file, this is what basically the data structure that the programmer is trying to define. Even in Postgres SQL also exactly similar kind of things is going to happen. I do not know what is the extension of that file name. That is the reason I am telling you like Oracle.
Maybe you may be right, because to that extent, I think we are not thinking. We are just thinking on the weak one level. But let us take it at the physical level right now. In the coming weeks, we should refine. I think also it should be refined, because we are ultimately we are learning from the IIT. So we should have a refined level of knowledge. 100% correct knowledge we should have. If it is possible, this simulation should be also there. How structures are made, a simulation should be there in the video form, because artificial intelligence world is coming in the education sector also. So why not start with this IIT level? Because we are beginning this online education system. I think so. If it is possible or not, I can't say. But it should be not on the paper like that. We are doing a screen and writing by the pen, writing pen. No, it should be a simulation level. This is the database, this is the extension, and the file is being stored like this, like a mechanical system or MATLAB in the electronics. What we learn in the electronics engineering, MATLAB software is there. If it is possible, then it can be designed. And it will be far better to understand this thing for the beginners who is not from the software background, like me.
Yeah. See, so I'm telling this is a just overview of the course. Whatever we are going to learn in this course, that is mentioned in the week 1. Okay. So what are different types of data structure we use, how we store this data, so that we're going to learn in the later part of the week.
Yeah, but I think the course overview was made like a text, like an NCERT book when we learned from the 8th class. Not like that. It should be in a simulation form. The database manager, this is a computer, this is a hard drive, and this is the management system. The simulation should be like that, so that the picture should be quite clear. Because we are learning on the paper, pen and paper. I think so. If it is possible or not, I can't say, I cannot comment, but I'm just of the dream that it will be like that.
Sir, probably a suggestion is like, if you can take that database diagram, right? And in the physical layer, basically what are
diagram,
the...
I'm also seeing the diagram is like a PPT.
I'm not telling you, I'm telling the instructors, like if they can provide a simple diagram, like how the files, like at the physical layer, like what are the different DBF files or control files, whatever, like when
you are
you define a table
absolutely right. Such type of things is not
that will give a very good understanding to the students that what is exactly a physical layer.
Yeah, 100% correctness should be there in the understanding that, because the lectures are good. Good lectures are there. A good understanding we have got from this. But for the questioning, a particular question, what level you are thinking about the database and internal structure, it should be clear when diagrammatically it is explained. Because this is intangible things. We cannot do this. Intangible things we can understand by the diagram knowledge. I think so. If it is possible, then we can do it. Or some instructor we can mind it, then you can
we'll note
do it and
your feedback, and we'll discuss with the team or core team also.
Yeah, this is not a complaint, sir. This is a system we are developing. This IIT is also developing the system. The whole country is working on this, I think so. We are also in the sector where education is being provided through the government portals, and there also work is being done. A number of institutions, crores of rupees also is being invested from the government account. But I think if it can be designed a better way, then it will be good for the future students. We are in the professional cadre, so we are just understanding.
Yeah,
and also,
if it is possible, sir.
Yes, you are right. But the problem is that if we take this part in detail, and actually what we are doing is that we are discussing the whole syllabus. Like in the week 4, we are going to discuss about the database design part. So if we go through the logical level, then we have to discuss the whole content. So that's why we are just doing the overview. As we go through this course, we will be getting familiar with the terminologies, how we are storing the data. So in the later week, we will be understanding in a better way. But you are right. Like we can just do the overview of what are the different level of abstraction is there, how we store, what type of what is entity, what is relationship, how to maintain those things. What is data structure we use? Only overview we can give that. Okay. In detail, it will not be possible. Because
and also, sir, like for these questions, right? If you can like be little more expressive, like that will be helpful, because otherwise, what is happening is, say for example, when you say file handling, like you probably took from week 1, but when I see that, I see it like a pretty general terminology, correct?
Yes,
so so this will lead to the confusion, and finally like you'll end up deducting the marks.
Yeah, see, Rajiv, the activity question is completely based on the slide and the professor lecture. So in the exam, you will not get, and we can assure that there is no such ambiguity. You not
okay.
Yeah.
And even in the also like similar thing like for graded questions as well. Okay, like try to like if there is any such ambiguity, like try to have a look at that.
See, most of this ambiguity comes in the theoretical question, right? When we're discussing this theory part, like question framing may be the
maybe yes, you're right.
Question framing, but when we are going to discuss about the conceptual or numerical problem, then it will be easier. But yeah, you are right. We'll take a note of it.
Please, thank you.
And it is advised if any ambiguity is there, please refer the professor video and what is the lecture lectured by the professor and the reference book, that is Korth, right? Hello.
Okay, sir. Yes, sir. Got it. You are audible, sir. I think what I have learned with this week 1, because in the foundation level, the content was well known to us. So we are just put our effort and got our foundational level. But here, new things we are learning, and we are having also the responsibility to develop this course in a good way, so that in the future this course becomes very fantastic. So at this level we can do something, then it will be better. This is our suggestion only, but still we are doing our hard. So we will, I think, consider for this also.
Yes, we are happy to hear some feedback. We are trying to improve.
Okay, thank you very much. So nice.
Yeah. Okay. So any other doubt? So yeah. So please, before week 2, please download and install PostgreSQL. Okay, and load the database also.
Okay, fine.
Okay. Yes.
You should leave now.
Sorry. Yes.
Now I think questions finished. More questions.
Yes. We can wind up this session.
Yeah.
Okay.
Okay.
We can leave now.
Yes. Thank you.
Thank you.
Thank you.
Good night. Good night.
Thank you, sir.
Everyone.
Thank you, guys.
Thank you so much, sir.
Yes.
So can you please explain database system internal, sir? Sorry, sir.